My name is Irina Guberman. I work as a principal product architect at Xaptum. It's a company that created Internet for Things, that, as we call ourselves. It's a network that's specifically designed for things rather than IoT as Internet of Things. So we won't go into much on details on that at the moment, a little later. Sure. So what we are going to talk about today is high-performance metric library options we were exploring at Xaptum because existing libraries didn't quite work for us. So the Xaptum case is where we had, let's say, 20,000 connections, each receiving 5 requests per second. And just putting existing matrix library on it didn't quite work for us because whenever the system load would get really high and things were getting rough and we really needed metrics, that's when the metrics would just not show up for us. They would work when things weren't so rough and we didn't quite really need them. Everything was nice and smooth. But whenever there was a bit of a problem in the system or we were overloading it, the metrics would not show up for us. So we kind of started exploring like we actually started deep diving into what are we doing here with metrics. And so we needed metrics to be not our enemy at the times of high load. We needed them to be our friend. And in order to, and that's a quote I came up with myself for the first time in my life, if you want somebody to be your friend, you have to understand them very well. So what we are going to do during this talk is kind of try to understand the kind of problems matrix library, like if you're creating a matrix library, what kind of things you have to be looking at. So you'll be trying to understand metrics. There is 2 sides to metrics. There is collection, and that's a tough problem, collection of metrics, because that's and then there is aggregation and reporting, and so collection has to be very performance. There, updating your counters might be happening thousands of times per second. So every process that we created thousands of processes, or like tens of thousands of processes accepting requests, and those processes will be reporting numerous metrics, maybe 10 different types of metrics. So that's sort of like a hard problem here. And aggregation, it has its own problems, but it's something that happens once a second. Reporting might be happening once a second. Aggregation might be happening even every 5 seconds. So metric collection is a performance critical, and you can think of it as a race car driver who's alone on the road, and every split second matters. And then aggregation can be done with a gen server. There's no problems with aggregation. You can think of aggregation as a race car driving crew that you can add more resources. It's not just one driver. You can have a crew of 10 if you need it. There is room for resources. They don't have a whole lot of time, but at least they don't do it very often. So you can think of race car driver versus race car crew for this collection versus aggregation and reporting. So let's take this problem to the beam. The language is on the beam. So how do we report? How would we report metrics on the beam? Everything is immutable, so that means safe concurrency. But when it comes to collecting metrics, it's a bit of a challenge. So how do we communicate information? Like a common way to communicate information in Erlang or other languages on the beam, it's by message passing. Or through a at stable. So let's explore gen server. Let's say we have a single metric collecting gen server. Most of you here know that that's an absurd idea. And I just threw it out there as a contrasting example, and maybe somebody who doesn't know. But if you have your millions or whatever, thousands of processes updating metrics in a single gen server, like literally in no time you'll have a problem with overflowing mailbox. And just probably everyone here, most people here know this problem. I just had to put it out there for people who maybe haven't dealt with this problem before. And if you haven't, you probably want to look into it. But then there is an idea. Maybe we can, instead of one poor gen server, we could have like thousands of them split up somehow, and then they would, during aggregation, they would trickle down that information. Like, it would be like a hierarchy of gen servers where you would be, sending metrics to, and they would be sending metrics to a smaller and smaller entity. That would be that's a bright idea, right? But that would be probably very complex. And the funny thing is that during tough times when we need the metrics most, again, metrics would not be our friend because we'll have exact same problem when suddenly even thousands of those metric collectors can't handle the overload of the mailbox. So we are back to the same problem, only probably at a much tougher, in a much tougher situation. So definitely much better choice is atstable. Atstable has its own problems. First of all, it's a complex structure, and it has table-level write locks. And so there is an update counter operation that allows atomic updates, but that's at the expense of locking the whole table. So only like one process at a time can write to a table. So if we have all the metrics in our table, now all our, it is much more performant than gen server, no doubt about that. But still, there is going to be contention of all of these processes trying to update this atstable. So here is another idea. Maybe we can have one metric point per atstable. Okay, but then if some metrics points actually are much more popular than others. Like for instance, if I want to measure just plain request received, not request type, but not split by request type or like by success or failure, but just like how many requests got into my server. That metric would be that metric would be bombarded all the time. And so this approach is not really going to help us. So now let's explore ideas that maybe are slightly like more generic than just Erlang problems. How about we split our counters per CPU? So it's sort of like every core will have its own counter. It will be, so that's an idea. It will be a higher burden on the aggregation time because now you have to add up whatever number of cores, number of counters, but that's aggregation problem. Remember, aggregation has more, during aggregation there is way more resources because it only happens once a second or once 5 seconds, mostly every 5 seconds. So we can postpone this problem to aggregation time. It's not a problem. So like if you were to do this kind of approach in C, there is no easy way, as far as I know. There is no easy way or OS-independent way to do it in C. But in Erlang, it's very easy because you have access to scheduler ID. That's the code to do it. And then you can find what's the number of schedulers. So with that, with this very useful functionality, we can explore further options. So now we can maybe think of a better atstable strategy. We can create atstable per scheduler. So if you think that every process will find out so we can create a number of, instead of one atstable to hold our metrics, we'll have as many as there are CPU cores. That's the code. You don't have to look at it, but just for your information. And then every process that's trying to write metrics will be accessing its own table. So it will find out what its scheduler ID is at the moment, and it will try to write to that. It will write to that table. So if you think about it, most likely there's going to be no contention. Of course, we can grab a scheduler ID and get preempted in the next second, in the next whatever nanosecond. But it's not very likely. Most likely, a process will be writing to this table corresponding to its scheduler ID. it's kind of like a trick. It's not a real binding of table to a scheduler. It's just a sort of mathematical trick to do that. But technically, we are minimizing the contention of a table, because that will be sort of like a table that belongs to a specific CPU. And that's the strategy that Xaptum, that's a very popular matrix library, is using. So we actually came up with a tiny repo that does measurements of various strategies. It's called Erlang counter bench. So it just measures various strategies. And if we compare adds updates versus adds update at a scheduler level, there is a tremendous performance gain, especially as the number of processes is going up. Like if it's only 10 processes in your system, which is not a realistic Erlang system, they're almost the same. But as the number of processes becomes more realistic, you can see there is a 2 orders of magnitude performance gain. Unfortunately, Xaptum didn't work for us, so we were exploring further options. And so my coworker, who's a C++ developer, and he works on, we have a like the front-end servers are written in C++, and our back-end distributed servers are in Erlang. So he created a metric library in C++, and he was exploring these kind of problems in the C++ world, while I was struggling with these metrics problems in the Erlang. So and he wasn't liking how there is no mutable counters. He's like, at least that very simple things can be done in Erlang. And so he did some. His name is David Bild, and he's a very brilliant coworker of mine. I'm very happy to work with him. So he was so he did a Google search if there is such a thing in Erlang as mutable counters. So he as a C++ developer, was thinking outside of immutable box, unlike myself. And he did that quest, and surprisingly, he found something. So we found this wonderful repo by Andy Till called oneup. It's a very simple set of NIFs. It's basically, so what you have is you can create an atomic counter, and you can, so there are methods to increment, and there's more than this. You can increment if less than. There is a few more, but it's a very simple repo. Basically, it boils down to this. The one thing that I should point out is that counter is a reference. So there is like no central access to it. Unlike @table, which you can access from every process just by its name, reference counter is not accessible from a central place. But hey, now looks like we don't have the Erlang kind of bottlenecks, like either @table problem being locked, or even gen server mailbox overflowing. Seems like we have something more interesting to work with now. So let's measure this guy. So of course, the measurements that I was doing, they're kind of artificial because I was just incrementing the counter. Your realistic problem, like your realistic server, won't be just updating the counter the whole time, right? Your processes will be actually doing some other useful work. But that's just to do some basic worst-case scenario measurement. Oneup counter isn't a whole lot better than adds per scheduler. It's just like 3 times better. But the thing is that I'll be talking about a matrix library that we wrote in just a second. We wrote it before I did this measurement, and it worked for us much better than Xaptum. I frankly, at this point, kind of can't tell you exactly why, but I just think that atomic counters, by their nature, they're just a much more suitable structure for matrix collection. So we came up with oneup matrix. We gave it a fair name because they were inspired and very much based on oneup, but we just put metrics around them, and we are trying to we are making it open source project. Open sourcing high performance metrics is not an easy task, and you'll see in a second. It's kind of an ongoing struggle. So the challenge for us is that, like I mentioned, there is no central access to reference counter. So how are we going to distribute it to all our processes and make it a friendly API for an open source project? That's basically the challenge now, because other than that, the library we wrote was actually working for us, and we had access to metrics even during very high loads and problems during. It was a very useful tool for us. Metrics did become our friend after we went with this approach. We actually were able to have introspection into our system. But making it open source, that's a different story. So this is like, since we don't have central access to it, it's sort of like an upside down problem for Erlang developers. So this is what we did, and I'm open to criticism here, but we have metrics configuration, which is very similar to Xameter. It will have like a list of atoms as a metric name. So configuration gets configured to a map, and this map is getting handled to basically every process that will be updating metrics. And to make the API friendlier, part of the repo, we will be putting the map into the process dictionary of that process, so you don't have to pass it around into every method or do any other, because there is no more complexity than that. But still, a person who uses our library has to understand that every process has to have sort of access to this map holding references. And if we put that into a net stable, we're going to be back to the problem that we had with that stable, no matter how efficient we try to make it. So now we have this other problem. We are passing around a map to every single process. So I created some very friendly methods there, which are just, we can say oneup metrics enable, and then suddenly the process has access to this metric. But if this process will spawn another process, and that child process will try to update metrics, it will have no idea what to update. So some more intricate understanding of this library would be needed. So I don't know if it's the best candidate for open source, but it was working much better for us than Xameter. That's the way it was. So there is two sides of it, just like we discussed. There is oneup metrics behavior for collecting metrics, and then there is gen server behavior for aggregation. And we created 4 types. It's very simple. It's much less. It has much less functionality than Xameter. It has only a counter, meter, gauge, and histogram. And histogram is actually very simple. It doesn't have a window of values. It's just basically will be sort of drop wizard inspired calculation, just like meter. But I applied a similar logic to histogram. So oneup matrix behavior, that's for collection. And there will be update method. And this update method is not a gen server method. It's just a process. It's just basically different type of metric will have a different flavor of update. And they also might have more than one counter. Like a histogram will have 4 counters. The counter of sample, counter of actual values, and then min and max. And it's going to be a very simple histogram, which is almost cannot be called a histogram, but it worked. Like we needed a very minimal. We prefer the reliable metric to. We prefer the reliable metrics library to a more powerful metrics library, because sometimes all you need is counters, but we even took it a couple of steps further. So we have the methods that are performance critical. They're for processes who have access to the matrix map that was passed to them. And they just have the methods that would be updating the counter. And then there is aggregation side to it, which is gen server calls that are only available to reporters and aggregators. But that's a safe thing to do, because those guys don't kick in until maybe only every once a second or every 5 seconds. So these guys will be actually doing more complex work. And the problem there is actually like the actual correctness of the matrix collection, but it's like a subject for another talk probably. We do try to do our best as far as correctness goes. So the problem with this, approach is a performance versus simplicity of the API. And next step for us is to explore better options. And another thing we found while we were running this library, while it was much better for us, it worked much better for us than Xameter, one of the metrics was still a bottleneck. It was still slowing everything down. I had to remove it. It was actually sending out requests. For some reason, that one was bombarded more than anything because it probably was we actually, when we do a fan out, there's going to be way more messages sent out than requests coming in. So that one metric actually killed our system, so I had to remove it. So that means that there was still a bottleneck even with this much more efficient approach. So the next idea is we could actually have an atomic counter per CPU. And that's basically in a stage of research right now. I just did some measurements with my little metrics program and that Erlang counter bench. And it turned out there is no benefit. But that's not because there is no benefit. There is just, this is a much harder problem to tackle. And I really didn't do enough work on it yet. It's just, that's basically the next steps for us. First of all, I was splitting the counter by using the regular Erlang approach with the schedulers, like I showed you before. And that approach itself probably introduces too much overhead for this to be beneficial, so I would have to move that back into the NIF. Well, that's just, it's basically just to show you what's the next steps for us to make this metrics library more efficient. And I would like to thank everyone who helped me with this presentation. Which is, first of all, it was David Bild, who we basically worked on this project together, and the entire Xaptum team. Then Andy Till, who was also very supportive while I was preparing this presentation. He's the creator of oneup repo. Also, an organizer of Elixir meetup in Singapore. I had this talk way before it was even ready for anything. Was for an online presentation in Singapore. And then also today I actually rearranged my whole presentation after speaking with Brian Trotwine. He's an expert on the subject. I should have spoken to him much sooner. But I swear I just rearranged the whole thing because it was not in proper chronological order, because certain things I discovered today versus before, but ultimately our oneup metrics repo is a winner anyway. So I strongly encourage you to give it a try. And also out of this conversation with Brian, I learned of a really awesome book he's writing on Rust, which is supposedly will give me a great understanding of C memory model, so I can actually fiddle with those for CPU counters, or maybe decide to not do that at all. But yeah, that concludes my presentation. Thank you very much, and it's time for.
Thank you, very nice talk. Have you looked at the hype bits? So I think there's a lot of people that don't know that if you compile the runtime system with hype, you get performance counters, for example. You can read the CPU performance counters, and you have an ink counter that's atomic, and all these things that the oneup thing builds is already since 20 years in the Erlang runtime system. So I think that's a little secret that few people know about.
No, that's not. We have not looked into that. And I actually, frankly, was expecting to gather more ideas from this talk, possibly not just share ideas, but actually gather them. So thank you very much.
Hi. A piece of information from the OTP news talk tomorrow, that this kind of EV counters using native functions is on the roadmap for after 21 release. We're talking about an array of counters.
That would be that would actually make our histograms much more powerful than what they are. an array of counters would be amazing.
And then I had a thought, an idea. Have you ever thought about using Xaptum for counting?
No.
Because that counts the number of calls to the function. So if you had a dummy module that you call when you want to update the counter, you would have a counter. And that one is designed exactly as you described, with one counter per scheduler aggregated at the end. So just a thought.
Great. We should probably talk more about it after the. Thank you very much.
You could mention that Annette's approach didn't work for you, but didn't even say why. Maybe you could share anything else.
Why Ed's approach didn't work?
Yeah.
Also, so what happens is when you write to Ed's table, the whole table gets locked. The entire Ed's table gets locked. So when you have, so while Ed's tables are actually very performant, when you have like millions of, not millions, thousands of processes trying to write it, metrics is like sort of its own problem. When you have, the system could be very well designed with Ed's tables and gen servers and everything, and suddenly metrics is this monster which suddenly is much bigger than the system that you have. So even Ed's tables become a bottleneck when you have these thousands of processes trying to update a matrix Ed's table. So like even splitting it into CPU somehow didn't help, and also splitting it by a metric name, it doesn't help because, like I said, if a metric is very popular, you'll end up still having a bottleneck there. But that's basic. The answer, the generic answer is that because of the table level write logs.
Write concurrency equals true. Write concurrency equals true. Stable setup. Can you help them?
No, we measured with write. The measurements I did was write concurrency and read concurrency equals true. That goes without saying. That didn't help. It was better. It was better, but not even better. And I actually had the metrics. I had measurements with the setting versus without. But that wasn't like without wasn't even the point of being there. Like I didn't even put it up there. I basically did explore various settings. It's not. This is sort of like a simple thing, right?
Any other questions? All right, thank you, Irina.